Okay, so for this week's Google Sheets assignment, you can click this link. I can't click it because it's my folder. And then you can, yeah, you should be able to click it and it should open up. Let's do that. Let's open it up first. So we got the data. I don't think it lets you really touch it though. If you go to Google Sheets, and then click Google Sheets. Make your own Google Sheet. Just have have yourself logged in like I have in the top right corner so you don't lose your work. And then if you go back to the data file, you should be able to copy and paste it. The quickest way to a lot of data. So the quickest way to copy and paste is to click the cell name this A at the top, hold Shift, and then click over to E, and then you can right click and then choose copy, hopefully. If it doesn't let you do that, downloading the data file and then re-uploading it to Google Sheets is the other option. And then over here, I've pressed Control V on my computer to paste it. Okay, let me know if you need help getting your data. Once we have the data in the spreadsheet, our first task is to gather 30 random numbers. So we know how to do that from previous weeks, right? Find an empty cell, type equals, type rand, open and close the parentheses, and there's a random number between 0 and 1. And then we got to click and drag that to give a random number to every number in the data set. Okay, I'm going to stop there, but we could click and drag the whole data set. And then click the top cell, the column name E, and then right click, and then we sort it from A to Z. Okay, so, or you could do Z to A, it doesn't matter. As long as you sort it by the random numbers. They'll change immediately after, but for a split second you can see they were sorted least to greatest there. So if you gave them random numbers and you sorted them least to greatest, click and drag until you have 30 numbers. Right click, copy them, and then paste them over to the side so we can work with them. So there's a random sample of 30. Okay, so that's step one. We did that. We stored the spreadsheet like it's asking us to. Now we need to calculate the mean, median, and standard deviation for our 30 numbers. So here's our new 30 numbers. I'm just going to type in some describers. Wait, what do we want? Mean? Median. Oh, we want median too. So median and standard deviation. So for the mean, I type in equals average, and I want the average of this column. Whoops, I forgot to open my parentheses when I was typing the word average. You got to open the parentheses to tell it some numbers are coming. There's our mean, the median, and then the standard deviation is equals stdv.s. Okay, so that's step one. We got the mean, median, standard deviation. Step two is to create a histogram. So just make sure that the instructions are for Google Sheets. You can definitely do it in Excel if that's what you prefer to work with. The instructions will be different though. So I'm going to highlight the data I want the histogram for. I'm going to click Insert, and then I'm going to go to, actually I'm forgetting, Chart. Okay, Insert and then Chart. And then it pops up a little window on the side here. We don't want a scatter chart. We're going to click that and find, histogram's right there. So that's a pretty non-normal distribution, right? Does not make a bell-shaped curve. There's an outlier in there. Okay. So you got to discuss whether your random numbers make a normal distribution, and then decide what's a better representation for the center, the mean or the median. You would use the median if there are outliers present. So for mine, I'm going to say the median is a better representation because the mean is going to get really pulled away by this outlier. Okay, so this next part, it's going to take a little bit of extra work, but it's applying the central limit theorem. The central limit theorem says that the mean is an approximately normally distributed variable. It means like if you calculate a bunch of different means, put them in a spreadsheet, and then make a histogram, it should make a roughly bell-shaped curve. So our goal is to make 15 of them. We just calculated one mean. We're gonna calculate 15 means all at once. Okay. So this is how you do it if you typed it all out. But this is how you can calculate the means really quickly. If you highlight all this table, and then copy it. So I'm going to click Edit, Copy, then go to your spreadsheet file. Okay, give yourself some room to paste it. Let's just put the data over here in column K. So I click the top of column K, I'm going to right click and click Paste. There, I didn't have to do any typing. It automatically calculated the 15 means that we need. Okay, so back up here, this part where all these instructions, we just bypassed all of it because we use this shortcut that I have for you down there. Okay. So we've got our 15 means for part 4. That part's done. Part 5, you're supposed to calculate the mean, median, standard deviation again, just like we did. So part 5, the final part of this, is to just repeat the process that we did with the first set of data, because the goal is to see that the mean is approximately normally distributed. So type in equals average, open parentheses, and then we want to calculate the mean for these. And then for the median, equals median, open parentheses, click and drag. And the standard deviation, same thing as last time. stdev.s, open parentheses, click and drag. Okay, so the mean is different. It's a little lower, which is a little more realistic for our data. The median, actually, one second. Okay, good. I wanted to make sure it didn't actually calculate the wrong column. That's right. Everything's good there. Okay, there's our standard deviation, and then the last step of part 5 is to do the histogram again, so we can hopefully see a difference. So I highlight my data, click Insert, Chart, and it's already making a histogram. So this is not perfectly normally distributed, doesn't have a bell shape. If we were to keep calculating means, though, I think we see the picture, it's getting better, right? This is way more normally distributed than that first graph is. So the mean, X bar, if you get a bunch of X bars, it should roughly make a bell-shaped curve if you've got a sufficient sample size. Okay, that's it. So once you have those 2 histograms, you get those 2 sets of means and medians and standard deviations, you're good.